When we use automated systems, how do we really know they're doing what they claim to be doing? For a long time, honestly, we just kind of trusted them. But as we've learned, that blind trust can lead to some massive failures. So today, let's dive into a really critical shift in thinking, how we move from simply believing a system to demanding hard, observable evidence for every single thing it does. So why is this shift so absolutely critical? Well, it all comes down to this number right here, an estimated 90%. That's huge. Of all errors from automated agents come from one single flawed assumption, the assumption of success. The system says it did something, and we just believe it, even when in reality it totally failed. And that kind of begs the question, right? Why are they getting it wrong so often? I mean, if a system can send out a command, shouldn't it know if that command actually worked? Well, the problem, it turns out, is this fundamental disconnect between saying and doing. This slide just nails the heart of the issue. On the left, you have what the agent tells us. Yep, action was dispatched or task complete. These are just words, right? They're statements. But on the right is the reality, what we actually care about. Did the action do what it was supposed to do? Is success actually verified? This gap between dispatching an action and knowing its effect, that's called the open loop problem, and it's where that staggering 90% failure rate is born. So let's put a name on this flawed practice. It's called agent self-report, and it's exactly what it sounds like. We're just taking the agent's word for it, with zero independent source of truth to back it up. It's like letting a student grade their own test. You could imagine how that goes. So the key here is we have to break this cycle of just trusting the report. The solution then requires a pretty fundamental change in our whole approach. We have to move away from a model that's built on trust and move to one that's built on pure observation. Instead of asking the agent what it did, we need a system that can independently watch what it actually does and record the cold, hard evidence. And that system has a name, TOB, which stands for the Tool Observation Bus. The easiest way to think about it is like a high-tech, always-on security camera pointed directly at your agent's actions. It's a core layer that sits on the server, completely independent, recording everything the agent does. It doesn't ask for self-reports, it just generates its own structured and, really importantly, tamper-proof evidence of what truly happened. Okay, so how does TOB actually organize this new world of evidence? It uses this really smart framework called the three-level truth model. It basically separates all the information into three distinct layers: what the agent says it did, what the system saw it do, and the rules that connect the two. This separation is absolutely key to building a reliable picture of reality. And this is where the model gets really, really powerful. By separating these sources of truth, you get clarity. At the very top, you've got claims. That's the agent's self-report, what it claims happened. We still listen to it, but we don't treat it as gospel anymore. Right below that, you have observations, and this is the ground truth, the real deal. This is what the tamper-proof server-side service actually saw. And finally, you have policy. Think of the policy as the referee. It's the logic that looks at both the claim and the observation and makes the final call. Okay, so the system is collecting all these raw, tamper-proof observations, which is great. But, just a giant stream of raw data isn't the same thing as meaningful proof, right? How does the system actually make sense of it all? How does it bundle related actions together to understand the bigger picture? Well, the first tool for this is something called the visit window. And you can think of it just like a container. When an agent starts working on, say, a specific web page or a single task, a visit window opens up and starts collecting all the related observations, every click, every scroll, every piece of data, into one neat, consolidated block of time. Now, inside that visit window, we can measure something incredibly important: dwell time. This isn't just about how long a tool took to run. This is the actual verifiable time the agent spent engaged on that page. Think about it. Did it just click a link and leave in a few milliseconds, or did it spend a couple of seconds there, which suggests it actually processed the information? Dwell time is a critical piece of evidence for meaningful interaction. And here's the big payoff for collecting all this structured data: the observations, the visit windows, the dwell time. It's that we can finally stop guessing. We can now look at the evidence for any given action and assign it a clear, simple grade. And here are those grades. The evidence can be strong, like we have a visit window and the dwell time was over a second. Boom, we can prove the agent actually read the content. The evidence can be weak. Yeah, we saw the agent was there, but we can't really confirm it read anything. It could be none, meaning we expected an action, but there's a big ol' evidence gap. And finally, it can be unknown, where we just don't have enough data to make a call. This whole system moves us from a simple pass-fail to a much more nuanced, evidence-based verdict. This all comes down to a really simple but powerful guiding principle from the source material. What the agent says is a claim. What Nova has observed is evidence. It just perfectly captures this whole shift from blind trust to verifiable proof. It separates what's alleged from what is fact, and that right there is the philosophical core of this entire system.
So, this leaves us with a final thought to chew on, and it applies to way more than just automated systems. If you can't observe it, if you have absolutely no independent evidence to verify it, can you ever truly, fully trust it? The move towards these observable, evidence based systems suggests the answer is a pretty clear no.